So here's a quick recap of today's lesson on calculating the area of composite shapes. So unlike yesterday's lesson, where we learned about estimating the area of composite shapes, when you're asked to calculate the area of a composite shape, you need a specific and exact answer. You're not just getting a roundabout guess. You are required to show your full calculations and you expect to get a fairly accurate response. Okay, so before we begin, there is a tool that you probably want to have next to you in order to help you with some of the formulas that are required. So moving over to my website, on my website, I'm just going to pull that up first. If you go to my class website, here it is, and go to the math web link, then what you'll see is at the bottom here is an EQAO formula sheet for the applied class. And on here you'll find all sorts of useful formulas that will help you calculate perimeter, area, and if I were to scroll down here, I can see some volume as well. Okay, so make sure that you're using the formula that's appropriate to the type of calculation that you need to do. So again, that was found on my website. I'm going to shift back to the note itself. And we're going to look at an example of a composite shape. So this is a composite shape because it has, maybe two or more different shapes that are kind of glued together. And we need to figure out what a measurement might be about them by separating them into pieces. Okay, so the question says, what strategy might you use to determine the area of the following composite shape? Well, the first thing you should do is take a look at the shape and see, well, in what ways can I divide the shape into shapes that I recognize and know the formula for. And so I'm going to go over to my smartboard and start to draw in some information that will help you to strategize and also to solve this problem in a way that's neat and understandable to the reader. So in this particular question, I see that if I separate along that line, I haven't drawn it very well, let me do that again. Separated along this line, then I have a rectangle right here, which I could call A1, and I have another rectangle right here, which I could call A2. So area 1 and area 2. Now, another way to go about this, which would be equally good, would be to separate this into two rectangles along the other edge. And both of those work perfectly fine. And so since this is the last one I've done, we're going to work with that. So I'm going to call this A2 and A1. All right, so now moving over to the side over here, I'm going to write it. Well, how am I going to find out what A1 is? I'm going to go back and color this blue so we remember what part we're talking about. So A1 looks like a rectangle of some description. It looks like it has a length right here that is 2 feet and a width over here that I don't really know. But what I do know is that the entire length is 6 feet on this end and 3 feet on this other end here. So this missing edge right here is going to have to be 6 minus 3, which happens to be 3. So now I know what that little length is, and it has to be 3 feet. Right? So the length times the width will give me the area in this case because it's a rectangle. So I'm going to say 2 feet times 3 feet will give me 6 square feet. Now I'm going to go ahead and look at the information that's given for area 2, my big rectangle. So area 2 is again a rectangle, so length times width. It looks to me whether I call it length or width doesn't really matter in this case. My length is 5 feet and my width happens to be 3 feet. So that will give me a total area of 15 square feet. The last thing that I need to do now that I have both of these individual areas is to say, well, I know that the total area is going to be area 1 plus area 2. And that will give me what I'm going to call my total area. So my total area is going to be that 6 feet from area 1 plus the 15 square feet from area 2, giving me a total of 15 plus 6, 21. composite shape. Let's move on to another example. All right, so in this next example, we can see that we have what looks like an ice cream cone that I can divide into two different shapes. So the ice cream portion right up here, that looks to me to be like a half circle or a semicircle. And I'm going to call that A1. And then on the bottom here, the cone portion, that is a triangle, and I'm going to call that A2. So I know overall that the total area is going to be equal to whatever area 1 is plus area 2. And so eventually I'm going to have to figure out what those areas are. So I'm going to start with that now. So area 1 happens to be a semicircle, right? So to solve for its area, I'm going to look at, well, what is the formula for a whole circle? And that is pi r squared. So pi times whatever the radius is squared. Since it's a half circle, and it's not a whole circle, but it's just a half of a circle, I'm going to divide by 2. Okay, divide whatever the area for a whole circle would be into 2 in order to get that semicircle's area. Let me go ahead and do that. So pi, remember, there should be a button on your calculator. If you're really stuck, use 3.14 as an estimate. Now I need to look at, well, what is the radius of this half circle? Well, this whole distance across, we call that the diameter. And I know that the diameter is equal to 2 times the radius. So since the diameter is 18, that means the radius has to be 9. So I'm going to say 9 squared. And then I divide by 2. Remember, the pi is not squared, only the radius is squared. So I'm going to go ahead and type that into my calculator to get an answer. Clean things up as I go. And I'm getting 127, approximately 127 square centimeters. As my answer. Okay, moving on to area 2. So area 2 is that triangle. So let me go ahead first and make sure that I include what area 1's dimension was. It was 127 centimeters squared. Now I'm going to get rid of this other portion of my calculation and work through the second half. So area 2 is a triangle, and the area of a triangle is always base times height divided by 2. So the base of this triangle happens to be the diameter of that semicircle at 18. So I'm going to plug that into my formula. The height, the h in that formula refers to the height of the triangle. The height of the triangle is this big long part right here, and that's 26 centimeters. And then I need to divide that by 2 because that's what the formula tells me to do. And that happens to give me 234 square centimeters. Okay, I need to put that into my overall total area calculation. I work that out. That gives me 361. And I need to remember to include my units, especially in my final answer. It's important to do it all the way through, but it's especially important to put in your final answer. And since it's area, it's units squared, and the unit in this case is centimeters. Right? Hopefully that example made sense. If not, you may want to ask me some questions in class about it. We're going to move on to our third and last calculation. All right, so this question is a little bit different than the other two that we've looked at. And in the question, they're asking you to find only the area of only the shaded portion. So let me highlight that so you know what we're talking about. We're talking about everything except for this circle in the middle. Okay? So this question is different because because we're not adding two parts of the composite shape together. The strategy instead is going to be, and you may have already thought about it, is to find the area of the square itself, the whole thing. Okay, so I'm going to outline that in blue. So the whole square, including the circle, I'm going to call that A1. So if I find the area of that whole square, including the circle, and then I find the area of the circle alone, which I'm going to call area 2, and I subtract that circle from the entire square, then that's going to give me my the area of the shaded portion. That will be what will be left over. Okay, so let's start with this. Well, break this down a little bit. Okay, so when trying to find area 1, it looks like it's a square. Okay, so but a square is just a rectangle. So I could just say the length squared, or I could just use the formula for rectangle, which we're more comfortable with. It just so happens that the length and the width are the same in this case at 3.2 millimeters. So 3.2 times 3.2, and I'm going to work that out. So 3.2 times 3.2 in my calculator gives me 10.24. And that ends up being millimeters squared. So I'm going to go ahead and plug that in where I have a 1 over here. So 10.24 millimeters squared. And now the only thing left to do is to find out the area of this circle here, which will enable me to find the overall area of the shaded part. So let's do that next. So the area 2, what I called area 2, happens to be a circle. And the formula for the area of a circle is pi r squared. So to solve this, I need to know what the radius of the circle is. So I'm going to go back over here, take away some of this junk, and see that a little bit more clearly. Okay, well, if the entire distance across the circle passing through the center for the diameter is 1.6, I need to know what half of that is to get my radius. And so the half of 1.6 ends up being 0.8. So I have pi times 0.8 squared, and I'm going to work that out on my calculator by using the pi button. Okay, so finding my pi button, pi times 0.8 squared gives me roughly 2.01, and that's millimeters squared. Okay, so I'm going to plug that in over here to my overall formula for the area. So I'm going to subtract the 2.01 millimeters squared from the 10.24, which gives me around 8.2 millimeters squared as my final answer. So if you did have any trouble with this, make sure that you take a look at the homework again, or ask me for some help with the homework. Remember that the solutions are all on my website on the Solutions tab. And if you need some one-on-one help with this, make sure that you're seeing me at lunch over the lunch hour, and we can do some more practice together.